All right, welcome to the video on inferences from random samples. As always, you should probably have the lesson open in a tab in the background that you can easily access as you go through the practice problems. It has a lot of good examples that you can read through that are similar to the problems you're going to be doing. So I'll give you a bunch of problems right now, and you'll have more on this lesson page. So you should have plenty of guidance. First thing, what is an inference? If you don't know what that word means, here it is right here, an example. When a random sample is representative of a population, we can make inferences about the population. Those inferences can be simple conclusions, estimations, or predictions. So when you want to infer something, you're making an inference. For example, if I pick a representative population of the school to ask what their favorite lunch is, and the most popular lunch is pizza, I can infer that because that sample had their most popular lunch as pizza, that the most popular lunch for the entire population of the school is probably also pizza. So that's what an inference is. Let's do some of these problems. Number one, a group of 185 incoming first year students at a university were surveyed randomly in order to determine the factor that influenced their decision to choose to attend the university. The results of the survey are as shown below. Soccer team 25, the available degree programs 55, the affordability 65, and the location was 40. So 185 responses, and those are the four reasons that those 185 first year students picked. So determine the population, the sample, and the conclusion of the survey. So the population is what the people doing the survey, it's the group they want to know about. So it says a group of 185 incoming first year students at a university were surveyed randomly in order to determine the factor that influenced their decision to choose to attend the university. So that's what we want to know, to determine the factor that influenced their decision to choose to attend the university. So they want to know about the first year students, and they chose 185 of them to ask. So the population they care about is first year students. Here it says all the students at the university as the population. That's incorrect because they only care about the first year students. Here, population, all the first year students at the university. So B so far is hitting the right thing because it says the population's all the first year students. Next, the sample. The sample is who they actually asked. They care about all the first year students, but they only asked 185 of them. So we're going to go ahead and choose 185 students. If we look at B, it says a group of 185 incoming first year female students. Does it say anywhere in here that the 185 students they chose were female? No, it does not. So B does not work anymore. C also identifies the population as all the first year students at the university, just like B does, but it says a group of 185 incoming first year students. That identifies the correct sample. Finally, what's the conclusion? The conclusion of the survey is what we can tell from the numbers. And according to these numbers, the affordability was the most popular response. It got 65 out of the 185 responses. Let's see what the conclusion is for C. The reason for the majority of the students to choose the university was affordability. Well, if we look at D, it says all the first year students of the university, just like C. And it says sample is a group of 185 incoming first year students, just like C. But its conclusion is the reason for the majority of the students to choose the university was a soccer team. But the soccer team is not nearly as popular a reason as affordability. So C is the answer. Number 2. 3 students from Milton Middle School are running for class president. A preliminary poll was taken in 3 homeroom classes, each with the same number of students. The results are shown in the table below. So here are the poll results, the students, Class A, Class B, Class C, and these 3 different candidates. These are the 3 kids running for student class president. Based on the preliminary results, who can be predicted to win class president? So who has the highest percentages here? Class A, 46% of them want Ian, 27% want Jesse, and 27% want Jeremy. For Class B, 37% want Ian, 29% want Jesse, and 34% want Jeremy. And for Class C, 45% want Ian, 9% want Jesse, and 46% want Jeremy. So It looks like Ian is the most popular candidate in 2 classes and almost the most popular candidate in Class C. So based on this, I would predict that Ian wins class president. Number 3, a manager at a publishing company randomly selects 7 employees, each from among the writers and the editors at the company. He records their typing speeds in words per minute and lists the data as shown. So the writers, and these are different numbers of words per minute that they can write. Editors, these are the different numbers of words per minute that they can write. So he's got 1, 2, 3, 4, 5, 6, 7, 14 data points, 7 times 2. The manager wants to use the data to estimate the mean typing speeds of the company's writers and editors. Remember, mean is the average when you add all the data together and divide by how many data points you have. Can the sample means be used to estimate the typing speeds for all writers and editors of the company, and why? So these aren't all the writers and editors in the company, it's 7 writers and 7 editors. Can we use this data? To figure out what the typing speeds for all the writers and editors of the company are? That would be mean typing speeds. So let's look through our choices. A, no, the sample means cannot be used to estimate the typing speeds of all writers and editors of the company because they are different from each other. B, yes, the sample means can be used to estimate the typing speeds of all writers and editors of the company because they are different from each other. C, yes, the sample means can be used to estimate the typing speeds of all writers and editors of the company because they are relatively close to each other. And D is no, the sample means cannot be used to estimate the typing speeds of all the writers and editors of the company because they are relatively close to each other. So you have no, they're different, yes, they're different, yes, they're close, and no, they're close. Those are your 4 options. So let's do a process of elimination here. Are all these numbers relatively close to each other? And the answer is yes. You got 67, 70, 68. Here's a 67, a 70, a 68. These numbers are not wildly different from each other. So I'm not going to say that they're different. I'm not going to choose option A that says they're different or option B that says they're different. So now we just have to determine if the fact that they're close together means that we can use them or that we can't use them. And the answer is we can use them. If they were wildly different from each other, then that would be hard to use that data because there'd be something separating the writers and editors' ability to type or how fast they can type. Because we're getting relatively similar data from both groups of people, we can use their sample means as a tool to estimate the typing speeds of everybody. Number 4, a survey was conducted in 2 different towns, Town A and Town B, to find the number of vehicles owned by each household. Each town had a total of 4,000 households. The survey was conducted by randomly selecting a group of 200 households from each town. The results obtained are given in the table shown below. So each town has 4,000 households, and we selected 200 households from each town. So which of the following statements about the data above is true? We have the data for town A, for town B. Each of these should add up to 200. And the reason that they add up to 200 is because that's how many that we chose from each town. So A, the estimated number of households with 2 vehicles is higher in town B than town A. Let's check that. Town B, 79. Town A, 79. They both have the same number for 2 vehicles. So would it be reasonable to say that one is higher than the other? No, it would not. So A is not our answer. B, the estimated number of households with 2 vehicles is the same for both towns. Yeah, it both says 79. Town A says 79, town B says 79 for 2 vehicles. So B should be the answer. Let's read through C and D to make sure we know why they are the wrong answers. C, the estimated number of households with 3 vehicles is the same for both towns. So we go look at for 3 vehicles. Town A, 36 households. Town B, only 27 households and 3 vehicles. So they're definitely not the same. So C is not the answer. And choice D, the estimated number of households with 2 vehicles is higher in town A than town B. And of course, they're the same number, so one is not higher than the other, and B is the correct answer. Number 5, the owner of a movie theater plans to offer rewards to frequent customers and wants to know what type of reward her customers would like to receive. She created 2 samples by randomly selecting 50 teenage and 50 adult customers at the theater. She surveyed each sample about which reward they would most prefer to see offered. The data gathered by the owner is shown in the table below. So we've got our data for the teens, here are the adults. There should be 50 of each because that's what it says that they surveyed 50 teenagers and 50 adults. So these numbers add up to 50, and this column adds up to 50 as well. Select all the statements about the overall populations of teenage and adult customers, which are supported by the data in the table. First thing, approximately 40% of all the theater's teenage customers prefer movie tickets as a reward. Let's figure that out. Now I want to bring up a calculator since we're calculating percentages so you can see how to do that. Okay, so I've got my calculator ready over here. I want to know if 40% of all the theater's teenage customers prefer movie tickets. So how many of the teenagers preferred movie tickets? 20. It's 20 out of, so out of, when you say out of, it's divided by the 50 that were surveyed. 20 out of 50 will tell us what percent 20 is out of 50. 20 divided by 50. We get equals, we get 0.4. 0.4 is 40%. So according to the survey, since 20 out of 50 students that are teenagers, I shouldn't say students, but 20 out of 50 teenagers preferred movie tickets, 20 out of 50 is 40%, so that statement is true. So again, if you want to know what percent 20 is out of the total, it told you the total is 50. 20 of those teens prefer movie tickets. 20 divided by 50 is 0.4, and 0.4 is equivalent to 40%. So this is an accurate statement. Next, a teenage customer is more likely to prefer movie posters as a reward than an adult customer. So let's take a look at that. How many of the teenagers preferred a movie poster? 11. How many of the adults preferred a movie poster? Only 5. Since there were 50 teens and 50 adults sampled, we can just look at which one is more, which number is higher. And the number of teens that wanted a movie poster is higher than the number of adults. So a teenage customer is definitely more likely to prefer a movie poster as a reward than an adult customer. Do be careful because sometimes you will get problems where there's not 50 teenagers and 50 adults. Maybe there's more of one than another, and you have to use the percentages. But in this case, because there's 50 teenagers and 50 adults, we can just compare the raw numbers. Next statement. More than half of all the theater's adult customers prefer movie tickets as a reward. Well, that's not true because there's only 23 adult customers out of 50 that preferred the movie tickets as a reward, and 23 is not more than half of 50. So this is not an accurate statement. Next one. Approximately 10% of all the theater's adult customers prefer theater snacks as a reward. Okay, so we take a look at that. Theater snacks, it does say 10, but this is not a percentage. This is 10 adults out of 50. And 10 adults out of 50 is not equal to 10%. Let's go to our calculator, and hopefully you can do this calculation in your head, but if you can't, it's okay. 10 divided by 50 is equal to 0.2, and that's 20%. So again, hopefully you know that 10 out of 50 is equal to 20%. Hopefully that number is second nature to you, but anytime you want a percentage, you can take the percent you take the number you have out of the total, do a division problem, and you get a decimal, and then you can find that percent equivalent. So this is not accurate. Next one, a teenage customer is more likely to prefer special seating than movie posters as a reward. Let's take a look at that. 4 teens out of 50 preferred special seating, but 11 teens out of 50 preferred movie posters. So is it true that they prefer special seating more than movie posters? No, it is not more likely to prefer special seating than movie posters. This is not accurate. Final statement to evaluate, here we go. An adult customer is more likely to prefer special seating than theater snacks as a reward. So we go over here and we see 12 adults preferred special seating, 10 adults preferred theater snacks, so more adults preferred special seating than theater snacks, so this is right. An adult customer is more likely to prefer special seating than theater snacks as a reward. Okay, next question. There are 1,500 apples in a cold storage room. Some are green apples and the rest are red apples. The manager of the cold storage facility wants to estimate the number of green apples in the room. He takes a random sample of 20 apples and records the number of green apples. He repeats this 15 times and records the data shown below. percentage of green apples in the sample, number of times the percentage occurred. So 15 times he chose 20 random apples. Of those 15 times, once 25% of the apples he chose were green. Of those 15 times, twice 35% of the apples were green. Of those 15 times, 3 of those sets had 40% of the apples that were green. So you notice that all of these numbers add up to 15. So this is representative of 15 different groups of 20. So the dot plot is shown below. You see one dot for 25 because there's one dot for the 25%. There are no dots for 30 because there is no 30%. None of the times that he chose a group of 20 apples did 30% of them be green apples. You can see the rest of the dot plot there. Let's get into the question. From the data, what is the best prediction for the percentage of green apples in the room? So if you had to guess what it was going to be again, if I have to guess which percentage is the most likely percent of green apples in that room, what's it going to be? Well, clearly, these ones were the more popular. 3 was the highest number, and it happened on these 3 groups. So these are more likely than the 25%, the 30%, the 55%, and 60%. These 3 numbers were the most likely percentages. And if you have to pick one of them, it stands to reason the most likely one would be 45% in the middle, because this is 40% just below, this is 50% just above. So 45% is probably the best guess there. And that's what this one says down here. The percentage of green apples in the room is 45%. Okay, next problem. This problem is a lot like an earlier problem we did. We've got a scenario here, and we're going to end up trying to determine the population, the sample, and the conclusion. So let's look at it. Brian randomly surveyed a group of 180 boys at his middle school. I'm just going to stop right there. The people you survey, that's the sample. So when we're looking through these groups, we're looking for a sample that says the randomly surveyed group of 180 boys at his middle school. So it's 180 the boys at the middle school. Which of our 4 choices say that the sample is 180 middle school boys? A says a group of 180 boys. It doesn't mention at his middle school. B says a group of 180 girls. That's certainly not it. C is a group of 180 boys. And D is a group of 180 boys. So none of them specify that they're at his middle school. But they do specify the 180 boys. B is not going to be one of our options here, or it's not going to be the correct option here because it says girls. So we can eliminate B from our choices. We know just from the sample that it has to be A, C, or D. Next, what did Brian survey those students for? He wants to learn what sport students thought should be played at the next middle school event. So he clearly cares about middle school students, and he wants to know what they think about the sports. So the population is boys at middle school. So it says all the students at the middle school. Well, this says sports students thought. So it doesn't matter for just the boys. He wants to know what all the students thought. He only surveyed boys, but this says that he wants to know what students thought. It doesn't specify boys. So all of the students at the middle school is the correct population. Now, the population for B, which we've already eliminated, said all the girls in the college. That doesn't make any sense. C says all the boys in the college. That doesn't make any sense. And D says a group of students in the college. That doesn't make any sense. All of the students in the middle school is the only one that makes sense, and A is going to have to be the answer. Let's look at the conclusion and make sure that that's accurate. The results of the survey are shown below. The conclusion for A says soccer should be played at the next middle school event, and soccer up here has 70 respondents that chose it, which is the highest number, so A is the answer. Okay, next problem. 2 random samples of 30 fans of the Blazers soccer team were asked whether the team would need an extra forward, defender, or midfielder for the upcoming final. In case you don't know, those are just 3 different soccer positions. The data gathered from the 2 samples is shown in the table below. So sample 1 had 16 people choose forward, 9 choose defender, and 5 choose midfielder. And sample 2 had 19 choose forward, only 7 choose defender, and 4 choose midfielder. Which inference is supported by the data in the table? A, most soccer fans think the team would need an extra defender or midfielder for the upcoming final. Well, The defender and midfielder for the first sample group, 9 plus 5 is only 14 out of 30. That's not most. 14 out of 30 is not more than half. So that does not seem accurate. Same thing is true for the second sample. 7 plus 4 is only 11. So only 11 people thought that the defender or midfielder should be added. Those are not more than half of. The forward is more than half. 19 is more than half of 30, and 16 is more than half of 30. So it's pretty clear that most fans think the team needs a forward. So A is not the answer. B, most fans for the Blazers soccer team think the team would need an extra forward for the upcoming final. That's true. Both of these numbers are more than half of 30, so that is true. Let's read the other ones to make sure we know why they're wrong. C says most soccer fans think the team would need an extra forward for the upcoming final. That seems like it says exactly what B says, but it's very small and important difference. B says most fans of the Blazers soccer team, and that is who was asked. Samples of 30 fans of the Blazers soccer team. Notice that C just says most soccer fans. That would include fans of other teams, and that is not the group of people that was asked. The people that were asked were only fans of the Blazers soccer team. So C is not right because it includes fans of other teams. D, most fans of the Blazers soccer team think the team would need an extra defender or midfielder, and that is clearly not right because, again, defender or midfielder were less than half of 30. So when I went over A, I probably should have pointed out that it said most soccer fans and didn't specify Blazers soccer fans. So we have no idea what most soccer fans think because we didn't get a sample that represents most soccer fans. We only got samples that represent the Blazers soccer fans. So B is your right answer because Blazers soccer fans think the team would need an extra forward. All right, here's another one. A small town with a population of 1,200 residents held elections for the position of mayor. 4 candidates had announced their candidature for the election. On the day of the election, a local newspaper conducted an exit poll near 2 polling booths with 2 groups of 100 residents each. The results are given in the table shown below. So in Group A, we had 51 pick Chris Jones, 6 pick Patrick Smith. Group A had 30 people pick Michael Small, and 13 people pick Susan Davis. And then you can see the numbers there for Group B as well. Which of the following statements about the above data is true? The estimated number of residents who would have voted for Susan Davis is higher for Group A than Group B. So let's go ahead and see that. Susan Davis. Well, Group A has 13, and so does Group B. So is it accurate that Group A is higher than Group B? No, it is not. So A is not the answer. B, the estimated number of residents who would have voted for Michael Small is higher for Group B than Group A. That is certainly true. 54 people for Group B voted for Michael Small, where Group A only had 30 people vote for Michael Small. So that does seem accurate. The estimated number of residents who would have voted for Michael Small is definitely higher for Group B than Group A. Let's look at C and D and make sure that they are wrong. The estimates for both groups show an equal number of residents who would have voted for Michael Small. That is not true. B is higher. Just as we just determined, 54 is much more than 30. And finally, the estimated number of residents who would have voted for Michael Small is higher for Group A than Group B. No, Group A has 30. That is not more than Group B, so that is wrong. And so the answer to B is correct. So another one, the students at Jillian and Kayla's school will be voting next week to select the theme for the next school dance. Jillian and Kayla have been asked by the student council to survey random groups of students to predict the outcome of the vote. They each randomly selected 40 students and asked them which theme was preferred. The results of the surveys are shown below. So we have Jillian's survey and Kayla's survey. How many students picked Under the Sea, how many students picked Tropical Islands, the Wild West, and Dragons and Castles. So complete the statements to make them true. Dragons and Castles is predicted by, and we select the drop-down menu and we have some options here. Only Kayla's survey, both surveys, only Jillian's survey, or neither survey to be the winning theme when the whole school votes. So if we look at Jillian and Kayla's survey and we check the Dragons and Castles section, would they be the winning theme? Well, for Jillian's survey, 15 is the highest number. So that would be predicted as the winner. But for Kayla's survey, 13 is not the highest number, 14 is. So we're going to say that Jillian's survey predicts that Dragons and Castles would be the winner, but not Kayla's, not both, definitely not neither. 15 is higher than any other number for Jillian's survey, but it's not the highest value for Kayla's survey. Both surveys predict that the Wild West, Under the Sea, or Tropical Islands will receive the fewest votes from the overall student population. So which one is going to receive the fewest votes according to Jillian's survey? The Wild West, because that's only 6. What about Kayla's survey? Also the Wild West, which is only 4. Both of those values are the smallest number for each of the surveys. So both of their surveys think the Wild West is going to be the least popular option. Next, using larger samples would make the surveys more accurate, make the surveys less accurate, or not change the surveys when it comes to the predictors of which theme will win the school-wide vote. This is a very important thing when it comes to statistics. More data, larger samples is pretty much always going to make your data more accurate. So you want to make the surveys more accurate by getting larger samples. The larger the sample would be better. That's pretty much always true. So always look for larger samples so that you can have more data and you can make your own predictions more accurate. And that's it. If you need more assistance, feel free to reach out. Have a great day.